Welcome to Clean Titans, where we explore the groundbreaking innovations and inspiring leaders driving the clean energy revolution. Today, we have the pleasure of speaking with Steve Heckeroth, founder and chief innovation officer at Renewables Inc. Steve is a pioneer in bringing electric solutions to the agricultural sector. Welcome, Steve.
Thanks for having me.
Steve, you have a background in architecture before moving into electric tractors. Could you share your journey and what inspired you to focus on electric solutions for the agricultural sector?
It's a long journey, but I'll try and do it quick. I was brought up in Southern California in the 50s and 60s when the smog was so bad it would hurt to breathe. And then I witnessed the Santa Barbara oil spill. And at that point, I decided I was going to dedicate my life to finding alternatives to fossil fuel. And that's what I've been doing ever since 1969. First, I was really wanted to be an architect, so I went to school to study that. I was part of the Back to the Land movement and moved up to Northern California on the coast and started building passive solar homes as soon as I graduated from school. And I got to the point where I felt like I could build a home that produced as much energy from the sun as it needed. So once I had done that, I thought, well, what's next? I wrote a little manual on passive solar design and how to buildings that take in the solar energy and produce all the energy. And then when photovoltaics came out in the early 90s, you could actually produce homes that made more energy than they used. So that was an energy plus home, which was pretty amazing when I felt like I could build a house that actually produced more energy than it used. I decided to move on to one of my other I've always had a garden, even as a little kid, and growing food is something that's really important to me. And I think that we've lost touch with the land, and agriculture has got such large scale that we really don't know where our food comes from anymore. So I wanted to build tractors that didn't rely on fossil fuel, that didn't pollute, so they weren't putting carbon in the air, because agriculture is one of the few things that can take carbon out of the air and put it sequestered in the ground. So it seemed like the ideal thing to do, both for growing food and for sequestering carbon. With the climate crisis happening, it became really clear that we had to switch our whole agricultural process to something that didn't pollute. Plants are what takes in carbon dioxide and then puts it in. And if roots stay in the ground, then we're actually taking the carbon out of the air and putting it back in the ground. So I switched my whole focus to building electric tractors.
Well, you were ahead of the game on net zero or net plus buildings. So, next logical thing is to electrify the farm equipment, right?
Absolutely. And it made so much sense because I first started building some electric cars, but the battery weight back then, it was lead acid batteries, and the weight was so heavy. I was converting electric Porsche Spyders replica kits, and the beautiful little sports car weighed less than 1,000 pounds without the engine and the gas tank. And I'd put 1,400 pounds of lead acid batteries in it to give it a over 100-mile range and a 0 to 60 time about 8 seconds. So it was one of the longest range electric cars built at the time. That was back in 93. But I just looked at that little car and thought, this is ridiculous, all this weight in this beautiful little sports car. And I thought and tractors actually need weight. At the time, I went to a tractor dealer and they had these 80-pound weights that you could buy for $80 a piece, and you put them on your front bumper of your tractor to hold the front down when you had a big implement in the back. And at the time, I was buying golf cart batteries that weighed 80 pounds a piece, and they cost about $80 a piece. So I could get my battery pack for the same money as these steel weights. So you could have your weight do something important, which is balance the weight of implements and add to the traction in the tractor. But weight over time, I realized that weight was kind of an enemy because it causes compaction. So these huge tractors that they're building, and then they've got to till up the soil and rip it, and they just end up with this soil that washes away with the wind and erosion from water. So I designed a tractor that went over the bed and didn't impact the soil. So all the soil could stay alive and act like a sponge to absorb water and not wash away. So that was what led me to start with big tractors and then get smaller and smaller to where I am now with the E2T.
Well, let's dive into Renewables Inc. What
Uh,
is the core mission of Renewables Inc. and what specific products and solutions do you offer to the agriculture community?
Well, the core mission is to develop an affordable, easy to operate solar electric mini tractor that can perform farm tasks quietly without emissions to make small farms more productive, profitable, and sustainable. So, to do that, I needed to really downsize the tractor. I was building tractors for vineyards, and they were saying they needed 70 horsepower and they needed about 8,000 pounds to pull the discs and the rippers that we're using between the vines. And then this regenerative ag movement started, and the whole wine industry is trying to be sustainable. When I was doing solar, I installed a lot of solar in the vineyards. So they were really ready for the most sustainable solution. So they were a good market for electric tractors. And that was kind of the initial market for renewables, and we wanted to solve their problems because they were driving these tractors between the vines that turned the ground into concrete because they were so heavy. So we came up with smaller and smaller tractors until we got to this little two-wheel tractor that is remote control. All the two-wheel tractors that are fossil fuel powered have handlebars, and you walk behind them. And that's initially I thought I'd have to have handlebars, but turns out remote control is cheaper than handlebars. Those handlebars have 13 different levers on them, clutches and brakes, and 3 speeds in forward speed. To operate it, you had to have a lot of upper body strength and a lot of weight to move it around. And a lot of the farmers are women-owned farms, and they couldn't operate those tractors very well. And to operate a farm with hand labor is very difficult. So they were all thinking that, well, I love farming, but my body can't take it. So renewables wanted to solve that problem, and remote control was a perfect solution because you just have a little hand unit that operates the tractor, and it requires no physical stress on your body.
Your two-wheel tractors aim to replace traditional diesel equipment. What are the key advantages of your electric tractors over diesel counterparts, such as in emissions, noise, efficiency, maintenance?
Well, it's actually because it's so small, and I said the remote control was actually cheaper than the handlebars and the 13 levers and all the mechanical stuff that was on the diesel tractor. So it's affordable. It's very quiet. So you don't have to wear the headphones and listen to all the loud noise. You can actually talk while you're operating it, and you can hear the birds sing and everything else like you'd like to do on the farm. Maintenance is probably the biggest issue for a lot of people because these all the fossil fuel machines require almost daily maintenance. You've got oil levels to consider, and the air intake filters have to be cleaned regularly. There's oil changes, belt changes, everything that you have to do. And then adding fuel is just, it's toxic, it's carcinogenic. It's not something you want to carry around and smell. So the electric motors that we have, a motor in each wheel, so that gives it the advantage of zero steering, which you can run the wheels in opposite direction to turn right around in a circle, or you can run one motor slower, one wheel slower than the other, and turn any direction you can, or you can lock it in a straight line. So it allows you to operate it very easily without any physical stress. The motors last 100 years without any maintenance, which is quite a bit different than daily maintenance on a gas machine. The motors have instant torque, which gas machines have to rev up to have their highest torque. So you don't get that instant torque that's really helpful in a tractor when you're pulling things and using it as a draft machine. Then we have a separate motor for the PTO, which is important as well, because when you've got one motor running the wheels and the PTO, then when something slows down, everything slows down and nothing works as well. But when you have a separate motor for the PTO, it always operates at the optimal speed. So you can vary the speed of the wheel motors and to get just the right, if you're mowing, just the right cutting. And probably the main thing people think about is that it's zero emissions, and that's becoming more and more of a concern, emissions with climate change and the CO2 causing the warming with the greenhouse effect. So with zero emissions, especially because this little tractor can be charged by on-site solar. So not only do you not have to breathe those emissions, but it's not causing climate change. So I think that's most of it. We designed it so it could use the implements from the fossil fuel machines as well.
There's health benefits to that zero emission for the people working on the farm.
For their lungs and their ears.
Can you elaborate on the capabilities of your electric two-wheel tractors and the specific farming applications they're designed for?
Well, it can do a lot of things that the walk-behinds can do, everything from preparing the beds to mowing, weeding, and you can put a harvest seat on it or a transplanting seat on it, which you can't do with a walk-behind. Or you can have those things like a transplanting seat usually goes behind a big tractor, and the people are breathing that exhaust all day long. But this machine you can use as a transplanting machine with a seat behind it, and there's no exhaust. You have total control of the speed, and it can be used for hauling just about anything. It'll haul a trailer that's 2 or 3 times its size. It's great for when you're harvesting. You can harvest from a harvest seat right behind the tractor and put the harvested vegetables in bins, and then you can haul them to where you need to haul them, all without any pollution or noise, and very easy to do.
How do these electric tractors enhance the productivity and sustainability of small-scale farming operations?
I think the enhanced productivity is because of the less stress on your body. When you're struggling to move this big machine, you just can't do it for very long. But if you've got a remote control machine or an autonomous machine, then your physical effort is not nearly as hard. So you can do a lot more with a lot less energy, and you can do it a lot quicker, especially compared to hand tools. To hoe a bed, 100-foot long bed of any kind of a vegetable crop will take you hours. But if you have your cultivators set up and you're using this tractor as a draft machine with cultivators, you can run down the whole row in 5 minutes. So it saves a significant amount of time, and time is money after all. So it's not only easier on your body, but it's faster to operate.
What are the primary challenges in electrifying agricultural equipment, and how is renewables addressing them, such as battery life, charging infrastructure, and cost?
The primary challenges were cost. When I was building the bigger tractors, the batteries were more expensive, but now that with regenerative agriculture and less heavy cultivation, a lot of regen agriculture is no-till or very low-till. So there's a lot less energy needed, and you can do it with a much smaller machine. And we're learning a lot about the different implements too. For mowing, using a sickle bar uses about 1/4 the energy of a big rotary mower or a flail mower. We did a demo with a sickle bar and just went right through this 3-foot high grass just as fast as it could go. And we tried a sickle bar on there, and it was a slow process. So it's a matter of picking the right implements so you can extend your battery life. And we also have exchangeable battery packs because we have this draft machine with high clearance to go over the bed. The wheel tracks are in the path. So the only compaction happens in the path. It doesn't happen on the bed. But that one, when we're using that same tractor with a PTO, with a power implement, you don't need that high clearance. So we can use that space for an exchangeable battery pack. And it does a couple of things. It allows us to put a very big battery pack, like the one that's on board is a 5 kWh pack. The exchangeable pack is 15 kilowatt hours. So you can get 4 times the runtime as you would with just the onboard pack. And it's easy to exchange. It just slides underneath the tractor, lowering the center of gravity and creating more traction, and gives you all the runtime you could possibly need. So we've solved a lot of the problems that we used to have with the bigger tractors because they just needed a lot of energy just to move them because they were so heavy. They weighed 8,000 pounds. This tractor weighs 250 pounds, and the exchangeable pack weighs another 200 pounds. So if you need more traction, you need more runtime, you can have the exchangeable pack. Just with the onboard pack and a solar shade canopy, this thing can run itself. To move it with a small trailer takes about 300 watts, and the solar shade canopy is 550 watts. So as long as the sun's shining, you can haul things around without any outside source of energy except sun.
So the solar canopy would charge the battery while it's operating, or
It's,
you have a
it'll
separate battery?
operate. It'll operate the tractor while it's running, and it will charge the battery. So it'll do both. It'll keep the battery charged, and then when the sun is not out anymore, you'll rely on the battery. But as long as the sun's shining, you can run it right off the sun.
Wow, that's great. So agrivoltaics could combine your tractors quite seamlessly.
That's one. Agrivoltaics are one of the things that is really interesting use for this tractor because it's so low to the ground. It's only 2 feet high. So they're building agrivoltaics 15 feet off the ground so that they can run a diesel tractor underneath there. The higher you get off the ground, the more structure you have to put on them so they don't blow away. The lower you get, the less structure. So you can build them less expensively, and you can mow underneath them, or you can. Solar industry has a real problem with weeds coming up and shading the solar panels. and they don't really have a way to deal with that other than poisoning the ground. So with this tractor, you can go right under the solar panels, and with agrivoltaics, you can grow crops underneath the solar panels. As the temperature gets warmer, you need more shade for the plants. And so having photovoltaics partially shade the farm actually helps both the plants grow, and the evaporation from the plants cools the panels, and they produce more energy when they're cool than when they're hot. So it helps both ways. It's a real synergetic relationship between photovoltaics and agriculture.
How do you see battery technology evolving to further enhance the capabilities and adoption of electric tractors?
Well, like I said, when I first started, all there was lead acid. And then they came out with first was the nickel metal hydride, which I worked for Stan Oshinsky, who was the inventor of that battery. And the Chevron kind of took over his company and buried that nickel metal hydride technology, but it was 3 or 4 times energy dense as lead acid. Now, some of the lithium that's come out is 4 or 5 times as dense as lead acid. So you can do the same. I had to put 1,400 pounds of lead in that Porsche Spider. Now I could get by with 1/5 of that weight in that Porsche, and it would be an amazing little sports car. If I wanted to do cars again, it's just amazing what it's opened up for cars to have these advancements in battery and
And the
energy.
density keeps getting better and better.
Absolutely. More important for us in the tractor than energy density is safety. And so we've focused on the lithium iron phosphate battery, LFP, which does not burn, which is kind of a bonus when you think about it. And it's just a little bit less energy dense than the ones that do burn, that have the combustible components in them. And so I think it's well worth the energy density, especially because we in the tractor industry, we need weight for traction. So it's not as big as a penalty for us as it is for transportation, where every bit of weight really matters. But on a tractor, we add weight when we want more traction. So the little bit of weight penalty of lithium iron phosphate is not a problem for us if it gives us a lot more safety and we don't have to worry about fires.
And what kind of charging infrastructure do you use on the farm?
Well, most of the farms we're working with have solar already installed on the farm. So it works just perfect with plugging it into a solar array. If you've got an exchangeable pack, so you charge it during the day and then you use it. You can exchange packs so that you can use it. Or if you're doing light work, like I said, that solar shade canopy can keep your tractor charged for hauling things around or doing light cultivation. Any of those operations will operate off the solar shade canopy.
So the chargers are at the barn and you just tractor
Yeah,
goes back to the barn, or you have multiple batteries that are charging there that you can swap out whenever you need to.
that's correct. You can just charge off the grid too. You can plug it into 110 or 220. And with 220, you can get a really fast charge, 5 kilowatt hour battery pack charging at 220. You can charge it in a couple hours.
And the newer technologies recently announced 5-minute charging. So that's just getting super fast.
You need quite a bit of infrastructure for that fast charging. I think that's going to be late coming to the farms.
They also have solutions where you don't need the infrastructure. You just need a battery bank.
You need to
So,
keep that battery bank charged though somehow. So
right, well, you have solar panels to charge your battery bank. So batteries getting cheaper means you can have a huge battery bank that would charge the packs from that battery bank storage. Not a grid.
That's like on our house, we have a battery. So if the grid goes down, we don't have to worry about it. And up on our homestead, we have 16 kilowatts of photovoltaics and some, I guess they're 1,000 amp hour battery packs. So we can go for weeks, especially if the sun's out. We don't have to worry at all. But when it's raining in the winter, we can still get by with the big batteries.
What are the biggest opportunities you see for electric tractors and other electric farm equipment in the future of agriculture?
Well, I think community scale farms are the biggest opportunity. I think, of course, you could have a swarm of these tractors that would go out and work on a big farm. You could automate them and have a swarm of them go out. But I'm more interested in farmers markets and local farms providing food for people so that they know where their food comes from and getting it as close to the people that are in Sacramento here. We call it farm to fork. So it's right where the farm is, what they're doing. If it's grass fed, you can go out and see that they're eating grass. They're not just finishing them on grass for a week and then putting the meat out there after grain feeding them or something. You can actually know the farmers at the farmers market. And those are the farmers that I want to supply this tractor to. Eventually, I'd like to expand that to subsistence farms all over the world where if they had this solar powered tool, they wouldn't have to rely on a fossil fuel network, which fossil fuel is what separates the rich countries from the poor countries, because it's allowed us to use this billion-year source of solar energy, stored solar energy up in a couple hundred years. We're going to use that billion-year stored that's accumulated in the earth. And then we're going to have to go back to solar anyway. So we might as well start using solar as soon as we can and save that precious resource that took so long to create for future generations.
Solar is getting so cheap, down to 1 cent per kilowatt hour. Countries in the south, like Pakistan, in the last 2 years added 22 gigawatts. In South Africa, Vietnam, many countries, they're adding amazing amounts of solar. I don't know, what does your tractor and batteries cost for the global south?
Our battery right now is about $500. So it's fairly inexpensive. All this tariff stuff and everything might change that. But the whole tractor, we're going to be selling them for about $7,500. Is competitive with the walk behind tractors that are diesel powered, but volume increases, we'll be able to lower that cost. But we need some high value markets. We might go into the greens mowing market because that's a very high value market. Yeah, automated tractor, a little zero steer greens mower, solar powered. That would be pretty cool. And I think we could get enough money for it that it would help us bring up the volume so we could offer it a lower cost to these other developing markets.
Beyond tractors, what other areas of agriculture equipment do you see as ripe for electrification?
Well, the implements tractor by itself really doesn't do much. It's got to have an implement with it. So I electrified, I think, one of the first tractor driven implements back in 1994. I put a motor on a mower and a lot of energy lost in the gears and the drivetrains of tractors. So if we can electrify implements, an example of that in a vine trimmer, that 25 horsepower to run this hydraulically operated vine trimmer. And it's the one that all the vineyards use. It costs $50,000 to trim each side of the top of each side of the vines as they go down the row. And it required a 70 to 100 horsepower tractor that weighed 8 to 10,000 pounds. And the heat from this hydraulic pump, they had to put a radiator on it, and it was the operators were just getting outside could be 100 degrees, but they were also getting heat in this like diesel engine and from the hydraulic pump and all the radiators blowing all this heat back on the driver. So we made an electric tractor and we electrified the vine trimmer, and we got the horsepower from 25 down to 3 horsepower by electrifying the vine trimmer.
Wow.
And then we went one step further using smaller trim motors that required much less power, because the power is related to the weight that you're spinning around. So if you can do that with a really light weight and do the same job cutting those vines, we got it down to 1 horsepower, and we only needed a 2,000-pound tractor. And the 1 horsepower vine trimmer that we made only weighed 200 pounds. So we could lower the initial costs from $130,000 for the diesel machine with a conventional hydraulic vine trimmer down to like $1,000. So cut it in a
Wow.
quarter. Yeah.
A huge difference.
So I think the future is electrifying all these implements, which actually do the work. The tractor do less of the work. It'll just be moving the thing forward, and the implement will be doing the work.
How do electric tractors contribute to the broader goals of sustainable agriculture and clean energy transition?
Whole fossil fuel industry is what's causing climate change that's happening now and weather events, and it's really affecting agriculture. Years ago, I used to buy an almanac, and it would tell you when to plant, when it was going to rain, and how much rain it was going to be, and everything, because it was really pretty reliable weather. But now that's all out the window. Can rain, it can pour and flood any time of the year, and it can be dry. In California, it can be dry for years in a row. So really hurting our agriculture by using fossil fuel. The hardest thing to get people to understand that is just the conservative mindset of the agricultural community. They want to keep doing things the same way they always have. And got these diesel tractors, and they think that they're powerful, and they get bigger, and then they have to do more and more cultivation, and the ground turns into dirt that doesn't have any life in it. And so I think that if we can change that mindset to care of the earth, taking care of the soil, building the soil, making healthier soil that makes healthier plants, that makes healthier people, then we can change everything around so that we're not trying to do things standpoint of old economics where we could get this thing out of the ground and for really cheap and sell it for a lot of money and make some people really rich while the rest of the people were getting poorer and poorer. But if we rely on solar energy, that's a great leveler of everything because everybody has access to that. And as you said, photovoltaics are now the cheapest source of electricity. So a no-brainer that we should start relying on photovoltaics for our energy and solar charge our agricultural equipment so that everybody has equal access to that. And we eliminate emissions that are causing the climate crisis and create a better future for our children and their children.
From your perspective, how important is it to electrify sectors like agriculture, which have traditionally relied on fossil fuels in achieving the global climate goals?
Yeah, got to stop using fossil fuel if we want our children to have the same access to a healthy planet that we had. And it's really easy thing to do now because takes are the cheapest source of electricity, and we can use that electricity to power our agricultural equipment. It can be smaller machines that can be small local farms that can feed their communities, half the problem of our current agricultural system is that we're growing monocrops in one place and they can't eat all that stuff in one place. So it's got to be shipped all over the world. And the shipping costs in money and in pollution, what's driving food to be so expensive and to lose its value, because the growing crops now, that how long they can store, not how much nutrition they have. The closer you get, the ideal thing is to have that garden in your backyard and you go out and pick that head of lettuce and make a salad, and you got your tomatoes and everything in your backyard, like a lot of people did with the victory gardens back in the time. And I think that needs to come back, where we've got a garden in our backyard. But beyond that, the people that don't have the ability to have that farm in an apartment or something, we need these local farms to be able to provide the food for their local communities and go as direct as you can from the farm to the consumer, rather than growing these huge that they can't possibly use in their local area. So they're shipped all over the world at great expense and at great cost to the environment.
What policy changes or incentives could accelerate the adoption of electric farm equipment?
Well, California is a good example of incentives for farm equipment. There's 3 programs in California. There's a Carl Moyer program that changes old diesel pumps to solar electric pumps. And then there's the farmer program that subsidizes the cost of switching over to cleaner tractors. I'm really disappointed that they didn't include in that. It has to be over a certain horsepower. And then there's the core program, which pays half the cost when you buy a new electric tractor. So the core program is really the one that's most. But I think Colorado has a program. Other states would adopt some of these incentive programs. We could move a lot quicker toward a solar electric economy and solar electric agriculture. I don't see that happening right away in the current political climate, but I think that the pendulum swings, and I think it swing back. And I hope the next time we from our mistakes that we made in California, the program gave about $500 million, switch out old diesel tractors with new diesel tractors. And the new diesel tractors were a lot of times less efficient than the old ones because they had all these pollution control systems on them. So that meant they were producing more greenhouse gas emissions. So I hope if any of the people from the California Air Resources Boards are listening, that they'll think about going directly to zero emission machines instead of cleaner diesel, which is just a half measure that doesn't address climate change. It only addresses particulates.
Well, luckily, technology is moving ahead really fast and making everything better and cheaper. So that would help.
Yeah, absolutely.
Renewables emphasizes innovations. What are some of the cutting edge technologies or features you're incorporating into your electric tractors?
Well, like I said, all the machines, gas machines, walk behinds have handlebars. And they have like 13 levers on there for doing different stuff. And when I started thinking about an electric, I wanted those handlebars if I could, because they were really hard to operate and try and figure out which lever you were supposed to push next. And it was hard to reach the brakes. Women can't even, their hands are too small to operate a lot of those machines. So I think going to remote control was the development that kind of happened because it was cheaper to do, and it didn't require any physical strength to operate the machine. So, and then some autonomy. We're developing to go straight down the row. So if you run into a rock with one wheel, that wheel will speed up so that it maintains a straight course. And there's other autonomous companies that we're working with where we'll have be able to like drive around, operate the tractor around a certain area, and then turn it loose to mow within that area. And it will be autonomous in doing that and have all the safety features to stop it if anything gets in its vision. Those new are really going to come fast. We started controllers, costs went down to 700 and now they're 150. It's shrunk from this big controller to something the size of a cell phone. And it does a better job, and it's got more inputs, and it's got CAN bus on it. So it communicates with 10 different things. So the technology is just incredible. It's like back 90s, there was this thing in California called the zero emission mandate. And that's when I started building electric vehicles. And every day you'd hear about a new company developing batteries or controllers or motors or something like that. And then that whole stopped by the Western Petroleum Association, the California Manufacturers Association, put $60 million into a negative ad campaign and killed the program. And then GM sued the state of California to stop it, and they killed it. They put back the advancement of electric vehicles about 15 years. And now I see the same thing happening where all these advancements are happening and all the federal programs have been cut. I hope that we can survive this cycle and get on to keep going, because it's incredible the innovation that's happening right now. Every day there's a new miniaturizes, just like with computers. The mainframe be the size of a house, and now it's the size of the head of a pin. And it does basically the same thing. And all those innovations can be brought into the things that we need to use every day. So we don't have to worry about the battery on the tractor. Everything else will last pretty much 100 years. But keeping it charged and not letting it discharge too much, and that stuff is all getting incorporated into what's a battery management system, and those are getting more and more advanced and protecting the batteries, so we don't have to worry about battery will be a lifetime battery eventually. So then will be like use something that is powered by the sun and doesn't pollute.
Most people don't realize that the batteries for a lot of electric cars and trucks and buses, and I'm sure for farm equipment, they have a second life as a backup storage. Once they
Absolutely.
once they are no longer usable in the vehicles, then they can all work as storage for a long time before they're actually retired or recycled. So
Yeah,
now
they
you can
usually take them out of a car when it's down to 80%, but 80% is a lot of, so you use that in a system and it'll go another 10 or 20 years and then recycle it.
Are you integrating any kind of sensors into your equipment?
Absolutely. More and more, the sensors that we put in there to communicate with a cell phone. So you can just hook up Bluetooth to keep track of the temperature of the motor, temperature of the batteries, the state of charge of the batteries. And then we can start putting devices on there and measure moisture. You could actually have something that put a probe down into the earth and you could measure what nutrients were missing. So extra nutrients that just washed off into the rivers and eventually into the ocean and cause those big dead zones. You could just use compost and certain minerals that are lacking that plants need, and you could measure those with the tractor, send it out, and it'll go around and take a probe every once in a while and bring back the information and tell you where needs more nutrients. So that's all coming. We could improve our soil's health instead of destroying it, like we have been doing for the last 150 years. You know, we've lost half our soil because of over tillage. We've polluted vast amounts of the ocean because of adding too much fertilizer. And that can all be reversed.
Where do you see the future of electric farming headed in the next 5 to 10 years? What are some of the most exciting developments on the horizon?
I think that just getting farmers realize that practices that regenerate the soil, of depleting it, we're whole country in North America is blessed with such rich soil, and there's very little of it on if you look at the globe as a whole. And so we've got to not only preserve what we've got, but now we have to rebuild and regenerate the soils that have been depleted. We have the tools to do that. We know how to do it. We've got like practices that instead of eating it down to nothing and then leaving it to wash away in the rain, we rotate the animals in a pattern that allows them to, it's that interaction in plants that makes the world, gives the fertilizer to be manufactured. All you have to do is put an animal out there and they will fertilize the ground and they'll tramp it into the grass and the will grow up strong and healthy animals if you don't leave them on the same place. If you don't put them in a little confined area where they destroy the soil. So if you rotate it around and then you get to it when the grass is growing up healthy again, and it's a cycle. We've got to get back into those cycles that make us healthy instead of the cycles that make us sick.
What about integrating some of those like lasers for weeding on your equipment?
I, I've seen that. It's kind of a high energy way to do it. There's a small farms around here. They've eliminated their weed with a layer of compost. They put tarps over, they grow crops, then they mow, and then they put a tarp down, and then they plant, and they pretty much their weed problem. You can watch what's going on with your soil. Then you can farm in a way that doesn't require these huge machines in a 600, 10-ton, no connection to what's going on, pulling this laser weeder that probably costs $500,000.
Absolutely. What has been the response from farmers to electric tractors so far? What are their main concerns and what are the biggest benefits they see?
Well, some of the women who operate farms who are just about to give up and get this machine, they say, well, now I can farm into old age. And, it's not hurting them. The reaction has been incredible from every place we've taken it. The people are just overwhelmed because it does the job faster without hurting their body. And it does it without pollution. It does it from solar energy in most cases, or you can plug it into the grid. But it's a machine that solves so many of the problems that small farmers are dealing with. The high cost of fuel, the constant maintenance, which nobody likes to do. And if you have somebody else do it, it's so expensive, you don't make any money on your farm. So you're almost tied to this vicious cycle of maintaining this equipment that's constantly breaking down. But with electric machines, the electric motor has one moving part. The gas or diesel has like 300 or 400 moving, and they all have to be lubricated and taken care of, and they all wear down. And electric motors, the parts don't touch. So all there is big bearings that last virtually forever. So everybody complains about, I go out to them, is all the maintenance that they have to do on their machines they're using. They look at this machine and there's virtually no maintenance. It's just electric motors and gears down to the drive wheels. And you got the PTO, which is just a motor. That's all it is. It's direct drive motor. There's not much to wear out, not much maintenance to do. And when we get the battery management systems dialed in, then the batteries will, like 15 years of life. And then afterlife for a home backup. So everybody we've probably a dozen. This is a fairly new product. So we've only done a dozen demos, but every demo we've done, they say they want one. So I think we're getting pretty good feedback. You can go on Instagram, Renewables 24/7, see some of the feedback, particularly from the women, because women are the nurturers. They like to nurture plants and they like to nurture their communities. And they're out doing really hard work. And if we can make it easier for them, they really appreciate it. And that's what we're trying to do. Make a machine that has no physical stress on your body. It operates very easily, requires very little maintenance or no maintenance. And like they say, right now. So that's the kind of feedback we've been getting.
So, any other factors besides the ones you just mentioned that are influencing the adoption of electric?
Well, I think the cost is probably the biggest one. Farmers don't have a lot of money. Most of the farmers are using old equipment because the newer, you can pay $500,000 for a tractor, a big tractor. But this little, you can compact tractor for like $15,000. And so what we're does pretty much the same thing, but it's half the cost. It is still money for people. We're trying to figure out ways to lease or cooperatives where several people could own the tractor and cooperatively own the implements. So the implements are bigger too. So we just got to keep trying to bring down the cost, but it's much easier to do with electric because fossil fuel isn't going to get that much cheaper.
Yeah, and as you say, solar keeps getting better and cheaper.
Yeah, what a great thing to be able to put down a solar array and have a solar powered tractor and be farming without any outside inputs. So, comparison to you buy a fossil fuel machine and you've got inputs every time you turn around. You've got to be doing something, cleaning filters and changing oil and trying to figure out how to get rid of that oil and buying fuel, and it's toxic, and it's just sun's rays coming down is all you need.
How can the agricultural industry and technology providers like Renewables better support farmers in adopting electric solutions?
Well, I think they could stop fighting in conservative group. They like to do the same way they always have. And if they just see what the big tractors are doing to the earth, which is what all the manufacturers, oh, you need this bigger tractor, you need this more power and more weight, and you need to deeper and do all these. And that's what the advertisements are. That's where the money is. That's where. So it's really hard to, from the other way, saying, no, just the first cost might be a little more, might even be cheaper, but down the road, you're not going to have to do all this maintenance and you're not going to have to destroy your soil. You're going to regenerate your soil with a lighter machine that runs in the paths for vegetables in particular. Also through the orchards, the vineyards, all that weight is making the soil less able to grow healthy plants. It's compacting the soil to the point where it's not able to be a vital source of plant growth. So just that point across that it's different. It might be better. That it's not what you see on TV. You don't see it on the media. All about bigger, better SUV, and that it's really anybody to even know about what the options are. I really appreciate you doing this, getting the information out there.
So you lead right into my next question. How important is education outreach in driving the adoption of electric farm equipment?
It's all important. I've been going to American Solar Energy Society. I chaired transportation for 10 years and did all the plenaries. I had people like Paul McCready, who was the inventor of the modern electric car, and Stan Oshinsky, who invented the nickel metal hydride battery and the thin film amorphous solar cell, and Bob Stimple, who in charge when the EV1 came, and Ed Begley, who's a big environmental, very important innovator and TV. There's only something to do though, because it's like you're always preaching to the choir. We've got to get out to media that isn't exposed. So the media, the side that says, oh, you got to go bigger, you got to put in more herbicides and you got to use chemical fertilizers. And that's the side has the money and has the ear of the media. So I hope more shows like this get word out that there is a different way to do it that will leave the planet better than we found it.
What are the main challenges and opportunities for a company like Renewables Inc. in scaling up the production and distribution of electric tractors?
Well, money is the biggest challenge. It takes probably at least a year to get this into production. And that whole year requires a lot of input. I've got a great team. It's a very small team. We are actually building the motors we're using, permanent magnet DC, most efficient motors you can build. And bearings are lifetime bearings now. So the challenge is getting the word out. We've got our website, renewables.com. You can go there and make a pre-order. And that'll give us, if we go out for investment, if we get enough pre-orders, that will allow us to say, yeah, there's people interested. We've got a market. Then we can move forward. So that the biggest challenge is getting the word out.
How do you see the market for electric farm equipment evolving, and what is Renewables' growth strategy?
Well, I was building bigger tractors. And I think to try and compete with big is really because the batteries are so expensive to do like a 30 horsepower tractor. You need a battery, several $1,000s. You're competing with power. With innovation, you can do it. But if you just try and compete power to power, a gallon has about 30 kilowatt hours of energy in it. A 30 kilowatt hour lithium pack weighs about 400 pounds, and a gallon of fuel weighs 7 pounds. A 30 kilowatt hour battery pack is $4,000. Doesn't compare. I think what we need is scale down to the community scale, have the food grown close to where consumers are so that there's not all that transportation. People could ride down and the farmer's market and get their food, or better yet, grow it in their backyard. It's compared to when you're trying to compete with the big tractors, they're going to be so much more expensive than the diesel machines, just because the cost of diesel machines is over time in fuel, and the gas tank hardly anything compared to a battery. So
People have to understand is the lifetime cost.
they think, oh gosh, this tractor costs $100,000 and I can get the same diesel for $50,000. But over the lifetime, that $100,000 electric will cost so much less over a 15-year lifetime or a 25-year lifetime, even better, because of all the inputs that you have to put into that diesel every year. And the maintenance and the fuel costs just keep adding up, whereas electricity is coming down in price, especially when you get it from the sun. But if you build a small electric tractor, it can be competitive in cost with a diesel tractor that does the same thing.
And are
Yeah.
there any opportunities, collaboration, or partnerships within the clean energy or agricultural industry that could
Yeah,
help accelerate this adoption of electric farm equipment?
yeah, absolutely. There's a lot of organizations that are dedicated to agriculture. And what I'm most encouraged is the regenerative ag organizations that are offering up these little challenges that I won the CAF. I don't remember what that stands for, but the CAF challenge. That was one of the first big ways that I got out there, was winning these various awards. I've applied for the International Solar Energy Society. So those are going to be really partnering with those kind of organizations and getting recognized, I think, is one of the best ways that I'm going to be able to get the word out there that electric tractors even exist. I mean, most people have never heard of an electric tractor. I mean,
Exactly.
probably 99% of people I talk to go, oh, there's electric tractors? Yeah, I've been working 30 years, but they haven't heard of it. So,
Well, maybe you can put agrivoltaic companies that are putting up the solar on farms,
I
and
am
then
doing that. I
so
wrote an article, Solar Today, on agrivoltaics 5 years ago. And I'm in touch with most of the big agrivoltaic developers. So that's good, because it's such a relationship where they've got this solar energy and they don't really know what to do with it. It's out on the farm, but an electric tractor is right there. It needs the solar energy. The new autonomous technologies, I think most of the farmers I'm working with want to stay in touch with what they're doing. They want to stay in touch with the soil, so they don't want to sit at a computer and operate their tractor. But there are certain repetitive, like mowing lawns and planting like cover crop pasture, where we could have automated so that the farmers do more tasks that require skill than just sitting on a tractor and driving all day. And I think automation is going to be really important to get some of the bigger ag operations on board, so they can see that it's not only environmentally sound. I think some of them don't want to hear about that, but maybe if it's money, saves time, maybe they'll think again about that it's for the environment, or that climate change is real or not real. But this will save money, and it'll save me all the time sitting on that tractor breathing in that exhaust. I'll go for that. I think the partnerships with autonomy will be really valuable as we move forward.
what message would you like to leave with our viewers today, particularly those who are involved in or interested in the clean energy transition and sustainable agriculture?
Well, main message is just talk to people and educate them that these clean technologies, they are affordable, particularly if you go life cycle cost. And if you do a life cycle cost of any of these clean technologies, it'll come out ahead. But even the first cost is getting down to where it's affordable. If you talk to anybody who's heard of electric tractors, have you heard of solar charged electric tractors? Have you heard of these small machines that can do the work of big machines without creating the compaction that destroys the soil? Have you heard about just the fact that it's the cheapest source of electricity? And solar can be powered anywhere, any place the sun shines. You can operate, you can do agriculture. Whereas if you're dependent on fossil fuel, there's very few places. To have them increases your productivity like 10 to 20 fold compared to hand tools. You can't do that with a fossil fuel machine, because it's just the infrastructure is just not most places. And that's what keeps all these countries poor, is that they don't have that infrastructure. And so they can't take advantage of a machine that helps them work more efficiently and more profitably, so they can feed their communities instead of just subsisting. So education and talking to everybody, just get the word out there that actually exists, and what I'd hope for.
Any plans to go to the global south, like in Asia, Africa, or Latin America?
I'm working with us in the business for a while too, and we did installations all over the world. And I am working with companies that are still doing and putting in like solar water pumps that now have to walk miles to get their water every day, and it's usually polluted water. But drilling wells with solar and pumping water and then operating little solar tractors is a way to propagate this throughout and improve lives all over the world.
So, any plans of making them in the local communities so it's cheaper?
I think most companies try and grow too fast, and that's why they fail. So we're focusing right here in California. Almost half the sold in the US are sold in California. So it's obvious that's the early adopter. And we've got dozens of farms right around our little facility. We're going out and convincing and showing people, and they're instantly convinced. We'll spread out there, and we have our plans to central facility in California to serve the whole California market, and then the whole West Coast, and then spread across the country, maybe setting something up in Canada, the Northeast, and then probably Central America will follow that, and then South America, and then we'll spread out from there. We are working with big solar companies that are installations in Africa, and they would love to partner with us to not only provide the pumping, but also the little electric tractor to help people be more productive. So I think we can spread out. India is another, it's the largest tractor market in the world. So it's another place we'd probably go.
Excellent. Well, Stephen, this has been a very insightful conversation. Thank you for sharing your vision and expertise with us.
Thank you. Thanks for spreading the word.
Steve, your work with Renewables Inc. highlights the importance of extending clean energy solutions to all sectors, including agriculture. We wish you continued success. To our viewers, thank you for joining us on Clean Titans. We hope this interview has inspired you to learn more about the role of electrification in creating a more sustainable agricultural sector. Please subscribe to our channel for more inspiring interviews. Join us next time on Clean Titans as we continue to explore the innovative solutions and inspiring stories that are driving us towards a cleaner, more sustainable world. And if you have any questions, please ask in the comments and tell your friends about us.